The analog traffic light is a working representation of a real traffic light in a final project that sums up the concepts learned in this course. Using the parts shown in the picture, a traffic light without any programming can be made. The traffic light is divided up into four parts. Firstly, there's a base traffic light without the pedestrian signal. The base traffic light is powered by a 555 timer and a decade counter. Diodes are connected to each LED to form a flash sequence so that different LEDs can be on at different durations in a repeating pattern. Secondly, the pedestrian signal is added on. This pedestrian signal is represented by a bicolor LED where red is stop and green is go. To drive the bicolor LED, an inverter is used in this formation. When there's input on the inverter, the green light turns on, and when there isn't, the red light turns on. So a wire from the green light is connected to the input of the inverter so that when a green light is on, the bicolor LED will turn green, and when a yellow or red light is on, the bicolor LED will turn red. Thirdly, there is the pedestrian signal that oscillates right before a yellow light. A transistor between the green light of the pedestrian signal with an inverter acts as a solid-state PBNC, so when input is applied, the green light will turn off. A square wave from a second 555 timer uses a solid-state PBNC and turns on and off the LED when powered only by the 8th input from the decade counter. This way, the green light will only start flashing right before a yellow light. Lastly, there's the countdown timer. The countdown timer counts down from 9 to 0 to signal exactly when a yellow light is about to happen. This is accomplished by feeding the clock signal of the second 555 timer into the 40110 IC, which outputs a sequence of highs and lows that form numbers on a 7-segment display and counts up or down. For this project, I timed the second 555 timer to produce a square wavelength that counts from 9 and stops at 0 when the traffic light turns yellow. For extra safety and to prevent any glitches, the reset pin is made high during a red, yellow, and part of a green light to always keep the count at 0 when not in use. Once the prototype was completed, I soldered it and 3D printed a case. Unfortunately, the soldered version is a bit finicky, but it does work as intended to as long as it doesn't move too much. Overall, this final circuit and the course as a whole has been a hard, rewarding, and useful experience. I definitely learnt a lot during it. Thanks for a great year.